All right, it's important to watch this video so you get some feedback on your scale factor assignment that was due last night. What you're looking at here is I decided to make all of the rectangles that have areas of 16 that don't have sides that are fractions or decimals. And I decided to make all of the rectangles that had areas of 36 that didn't have sides that were fractions or decimals. Many of you did the problem differently, which was fine. Some people use triangles, some people use trapezoids, and those could work. But many people did not choose two shapes that were similar, and many people did not choose shapes that had an area of 16 and an area of 36. So I decided to make this problem as simple as possible by only using whole numbers and only using rectangles. So in the problem, there were three requirements that you had to meet. The first one was the areas had to be 16 and 36, and all of the pictures that you're looking at either have areas of 16 or 36, so I've met that requirement. There are no squares allowed. Now, a square can work to help you find the pattern that we're looking for, but I wanted to make the problem a little more complicated, so I eliminated squares as a possibility. So we're going to get rid of the squares right away so we don't have to worry about those. And so now what we have to decide is, of the shapes that are left, how many of the ones that have an area of 16 are similar to the ones that have an area of 36? So I'm just going to show you two examples. One example that doesn't work and one example that does work, and then we'll work with the shapes that are similar. So I'm going to start by comparing rectangle number 2 to rectangle C. So in rectangle number 2, you can see that it has a height of 1, and in rectangle number or letter C, it has a height of 4. So far what that's telling us is that rectangle C is supposed to be 4 times bigger. But when we compare the widths of height of rectangle 2 is 16, and the width of rectangle C is only 9. And so while the height got 4 times bigger, you can see that the width definitely did not get 4 times bigger. So rectangle 2 is not similar to rectangle C. And if we tried that same thing with all of the rectangles, rectangle 2 is not similar to any of them. So I'm going to get rid of rectangle 2 right away. All right, so here's what it looks like to find two shapes that are similar. I'm going to compare rectangle 1 to rectangle B. So rectangle 1 has a height that is 2, and rectangle B has a height that is 3. So for every 2 squares of side length in rectangle 1, there's 3 squares of side length in rectangle 2. Now let's try the widths. The widths of number 1, the width is 8, and B, the width is 12. And if we reduce that fraction by dividing the top by 4 and the bottom by 4, the ratio of the widths is also 2/3. So those are similar shapes because the sides grew at the same rate. The height grew from 2 to 3, and the width grew from 2 to 3. For every 2 squares in rectangle 1, there's 3 squares of side length in rectangle B. So those are the similar shapes. So none of the other pairs of shapes are similar. So we're going to get those off the screen right now. And we're just going to take a look at number 1 and letter B. And so we found our two similar shapes. So we already know that the side lengths are in a ratio of 2 to 3. That means that the scale factor, which is just the ratio of the side lengths, is also 2 to 3. If we find the ratio of the perimeters, to find the perimeter of number 1, we would add 2 plus 8 plus 2 plus 8, which is 20. And the perimeter of letter B would be 3 plus 12 plus 3 plus 12, which is 30. So if I divide the top by 10 and the bottom by 10, I'll get the fraction 2/3. So you can see that the ratio of the side lengths, the scale factor, and the ratio of the perimeters all come out to 2/3. Now when we look at the ratio of the areas, this was already given in the problem. So the area of number 1 is 16 and the area of letter B is 36. If we divide the top by 4, we get 4, and the bottom by 4, we get 9. So while the sides, the scale factor, and the perimeters all have a ratio of 2 to 3, the areas have a ratio of 4 to 9. In your problem, you should have gotten the same red numbers that I did, regardless of what shape you used, whether it was a triangle, a trapezoid, a rectangle, or any other shape. As long as the small figure had an area of 16, the larger figure had an area of 36, and they were similar shapes, your results should have looked just like mine. Now, this is important. There's a pattern in math that you're supposed to have learned by doing this activity. It looks like this when you look in a textbook. They would say that the ratio of the side lengths is A to B. The ratio of the perimeters is A to B, and the scale factor is A to B. Now, obviously, when you look at the numbers, when I look at the ratio of the areas, I'm not going to write A to B. So what's the pattern for the ratio of the areas? And it turns out the pattern looks like this. It's the scale factor squared. And so our scale factor was 2/3, and the ratio of our areas was 4/9. So this is the nuts and bolts of how this exactly works. If you know the scale factor, and you want to know the ratio of the areas, then you take the scale factor and you square it. In our problem, we knew the ratio of the areas, and we wanted to find the scale factor. So in our problem, we had 4 to 9, and we wanted to turn it into the scale factor. And so instead of going from the scale factor and squaring it, we have to do the opposite of that, which is take the scale factor, or which is take the ratio of the areas and square root it. So the square root of 4 is 2, and the square root of 9 is 3. So this right here is the pattern that you're supposed to know about the ratio of the areas and the scale factor of two similar shapes.